Hi there. All right, so yesterday we learned a couple shortcuts to proving triangles congruent. Guess what? There's a couple more. So we're not tied to just those two shortcuts. We have a couple more: angle, side, angle, and angle, angle, side. So this time, instead of working with sides, we'll probably work a little bit more with angles. And again, the order that you select those two angles and side is important. On angle, side, angle, you're going to be given this angle. Well, you're going to be given two angles, and it's always the included side, that side that falls between the two angles. That's angle, side, angle. Remember, you kind of have to wrap around the triangle in that order. And if you can show those three congruences in these two triangles, then that's enough to show the triangles are congruent. The other one is angle, angle, side, and that's two angles and the not included side. So that would look something like this. Here's an angle, and then you come across another angle, then a side. So that side does not fall between your two angles. And if you can show that in your two triangles, then those triangles will be congruent. All right, so as promised, we're going to do a lot of proofs in this chapter with these congruent triangles. It's kind of a great way to reinforce all those previous theorems and definitions that we've learned, because we're just trying to come up with a bunch of congruences so that we can get these triangles congruent. All right, so let's start off with this one. They give me two congruences in the given part. You can see here that I've got the angles congruent and the segment congruent. That's right here. It's interesting that they even gave me, oh, you know what, I was going to say those are vertical, but I don't think those are vertical, because see how this does not really extend straight? Those are not vertical angles. So good thing they gave them to me. I've got those two congruences, and I've got these two segment congruences. And then they come back and they tell me that angle B and angle E are right angles. So that's marked in the picture, but that doesn't say they're congruent. I have to have three congruent statements. I only have two. But this one's going to lead me into one right away. What do we know about right angles? Well, yeah, we know they equal 90, but even better yet, if you look at your list of theorems and definitions, we also know that all right angles are congruent. So I'm going to come back right away and say angle B is congruent to angle E, and that's because, oh, I forgot to write given up here. And then that's because all right angles are congruent. And right there, I've got my third congruence. Now let's look, is it the right congruence? If these are going to be congruent, now when I look at my triangle, I've got an angle and an angle and the side that's in between there. So that looks like an angle side angle situation. I'm going to go ahead and say my triangles are congruent. And I'm just copying that from the prove statement up above, and I'm going to call that angle side angle. So this all right angles congruent, that's one that we can use a lot to add in another congruence. All right, let's try again. This one, they've got all the statements done for me. I just have to fill in the reasons. All right, so looking here, I've got angle M congruent to angle K, and they have that marked in the picture, and that's my given information. Now, interestingly, if you look at your given information, there's two different sets of given. Now, only one of them is a congruence. The other one's a parallel lines. I'm probably going to do some parallel lines cut by a transversal business here, but this is really the only congruence, and they've only given me one. So for whatever reason, they broke that into two lines. So that's lucky for me. I got another reason already given. Now let's go look at what that can give us. They're kind of trying to help me out with this angle MWR. MWR, that's this angle. And KRW, that's this angle here. All right, and it's saying those are congruent. Well, let's look at this. Here's my parallel lines. I always like to extend them so we can see what's going on. Here's my transversal. Parallel lines cut by a transversal. What kind of angles are those? Those are alternate interior. So I'm going to start off. If you have parallel lines cut by a transversal, then alternate interior angles are congruent. All right. And then what else do we have? WR is congruent to WR. Now, if you look at your picture, I'm going to get rid of all that extra stuff that kind of is cluttering up my picture. I just showed, let me get those angles marked. It was this angle and this angle. And now they want to say WR congruent to WR, that's this segment. Okay, that's just a reflexive. When you have the same thing equal to itself, that's reflexive property. And that's my third congruence. Now I have to look back and say, what did I just show? As I wrap around the triangle, I've got two angles and a side, and that side is not the included side. It goes angle, angle, side. So my triangles are congruent by angle, angle, side. Okay, so on this one, anytime you get that parallel lines, be looking for the old parallel lines cut by transversal theorems. And then, of course, reflexive is always fair game if you have two triangles that share a side. All right, here's our next proof. We're on our own here, it looks like. So very beginning, I'm going to go ahead and stick in all of my given information. Angle S is congruent to angle Q. That's already marked in the picture. I'm going to go ahead and throw all this stuff in here. RP bisects angle SRQ. That's a given. Now that's not marked in my picture, so let's see what that means. It doesn't say congruent, but I bet I can turn it into a congruent. RP bisects SRQ. SRQ. So if this is bisecting this big angle, what's that mean for these two angles here? Okay, those angles are going to have to be congruent. So let's list that. Step 2, angle SRP is congruent to angle QRP. And that is because it bisected it. And remember, anytime, because that's what it did, that's a definition. Definition of a bisector. Now by doing that, I'll go ahead and mark it in my picture, but I've kind of used up my given. So now I'm going to the picture to see what else I can find. And like I said earlier, hey, look, these two triangles are sharing a side, so I could certainly do a little reflexive step there. Let's do segment PR is congruent to segment PR, and that's reflexive. And that was my third congruence. Now I look at the two triangles and figure out what I got. I got two angles and a side. Does the side fall between the two congruent angles? And no, it does not. That would be this one. That would be angle, side, angle. That's not what's going on. I got angle, angle, then a side. So triangles are congruent. All right, triangles SRP and QRP are congruent, and that's angle, angle, side. Okay, hopefully these proofs aren't too bad, because you really are just gearing up, trying to get those three different congruences in there and using kind of all those different definitions and theorems we've previously learned. All right, so now let's look at these triangles that they tend to overlap a little bit, or they share something, and so our goal here is to figure out that whole reflexive thing. If you can find something that they share, that's an easy congruence to add in. So on this example, it says, what common angle do triangle ACD, this triangle here, and ECB share? It says, what common angle? Well, don't they both have the C in it right there? Yep, they both use angle C. So then I would be able to use that as a reflexive situation. Okay, let's look at this next one. This is a little bit trickier because there are a lot of different triangles in this picture. So let's make sure we're dealing with the right thing. I'm going to go ahead and do a little highlighting here. We're talking about triangle, it says ABD. So we're talking about this ABD. So we're looking at this blue triangle, and we're comparing it to then triangle DCA, this one here. And if you kind of really draw them, and maybe different colors should help a little bit, you can see what's the common side. Well, which one did I color blue and green? Well, it's that side AD. That's the side they share, and so if I was doing a proof, I could say AD is congruent to AD by reflexive, and that'd be an extra congruence. All right, so with that said, let's try one that kind of looks like that. When I look at these two triangles, and you can see what I'm trying to prove here, triangle PQT PQT, this triangle, and triangle PVR. Okay, what angle do they both share? Angle P. So I know I'm going to do an angle P congruent to angle P by reflexive. I guess let's go ahead and look at what else they've given me though. They gave me angle T congruent to angle R. That's given. And you can see it's marked in the picture. And then they have PQ congruent to PV. That's not marked in the picture, so let's mark it. Okay, and so then you got this angle here and this angle here. And then I'm going to throw in my reflexive step. Angle P is congruent to angle P by reflexive. That was bad. Okay. Now, so then I'm going to do like a double. And now I have to kind of look at my triangle. My PQT triangle here. PQT. And if it helps you, sometimes I think it helps to like pull that out of there and redraw it so you can see exactly what you've got. I've got this marked with a single mark. I've got this marked. And then you can see that I have a chunk of this marked, like right here, but that's not the whole side, so I'm not going to do anything with that. But I do have this angle up here. And then you can kind of see, oh, that's an angle side then. All right, I got my triangles congruent, PQT, congruent to PVR by angle side. All right, so be looking for things that share. That's what that proof is about. All right, and just because I can't get enough of them, let's do one more proof here. Proven triangles congruent, they're overlapping here. It's a little bit tricky when you get those overlapping triangles to even kind of tell which ones you're dealing with. You got QDA. QDA. All right, I'm going to kind of draw that triangle over here. QDA looks like that. And you can see then for what's given, QD congruent to UA, so that's this leg right here that they have marked. And then they have angle QDA, that's this big angle right here that's marked. And then they have those same things marked in the other triangle. I'm just kind of drawing that left triangle, but I guess maybe I'll go ahead and redraw. This is my DAU triangle. And you can see that they have this marked and then this marked as congruent. Okay, those are the two triangles that I'm dealing with. Got two congruences given to me. What I need is the thing that they share. When you look at that picture, what is the side or angle that they both are using? If it helps you, draw it over it and look and see what gets colored twice. And you can see it's this DA that gets colored twice. Right. So then that's going to be my step 2. I'm going to say DA is congruent to DA, and that's reflexive. Forgot to write my given. All right, that's 3 congruences right there. See, these aren't that tough of proofs. Now, the trick, though, is, let's mark that picture. DA was this leg, which shared with this leg. And now, why are my two triangles congruent, do you think? I'm hoping you're saying by side, angle, side, because that's what you got. 2 sides and that included angle between the 2 sides. Okay, so then the last little bit of this is we're going to practice doing some constructions where we're constructing congruent triangles by a certain method. Now we've done the side, side, side. We did that previously. We did it yesterday. Let's see, how would you construct a triangle congruent to this one by using side, angle, side? Because ideally, this is supposed to, if I have these congruences, if I can make another triangle that has these same congruences, it should create a congruent triangle. All right, so to do that, I'm actually going to start with my angle. I'm going to start with the middle thing. And remember that you can always look on the website to see how to construct these, because I'm kind of freehanding this here. But what I'm going to do is I'm going to start off, and I'm just going to draw a random segment that's supposed to represent this segment here. So I'm going to draw it plenty long, because that's a long leg right there. So with my ruler, I'm going to draw this really long segment here. so that it's plenty long. And then what I have to do is I have to construct a congruent angle. So this takes us back a little bit. We haven't done a congruent angle in a while, but to do the congruent angle, you have to put the point of your compass right here and make an arc through that angle. And then you're going to come down, and since you're copying that angle, you're going to do everything exactly the same. I'm going to put the point of my compass here, and without having moved that compass, make that exact same arc right here. And what I'm doing is I'm saying, okay, make that arc at a certain distance from your vertex. Now measure how wide that is. So put the point of your compass here and measure how wide that angle is. And then you copy that width of that angle down here. Put the point of your compass here and put that same arc up here. Now at any point you can pause this video and get your construction done, get caught up, and then start it up again. Now what I'm going to do is take that right there, dictates how wide that angle is supposed to be. Now my triangles are going to overlap because I didn't leave myself much space, but I'm going to make this plenty long because this is actually representing or going to represent or correspond to this leg, so I want to make sure it's at least that long. So what I have is this angle that matches this angle. That's the included angle. Now I want to make sure the two sides that surround that angle are the right length. So that means I need to make this leg, or really I'm making this leg, match this leg. And I'm going to make this leg match this one. So that means I need to measure these with my compass. So I'm going to change this up, change colors. I'm going to put the point of my compass right here and measure how wide this segment is and put an arc down here. I'm going to take that length right there, put the point of my compass here, and put that same arc right there. So now I know this segment is supposed to be that long. All right. Now I come back, put the point of my compass back here, measure how long this one is, and put an arc through there so I know that you've measured that. And you come down here and you mark off that same distance. And then you can come back and you're going to join those two parts together. Oops, sorry, that was kind of bad. Join those together, and that forced these two sides to be congruent, so now I have a congruent triangle by side, angle, side. Okay, if you need to practice that again, you can rewind that video, or rewind here and re-watch that. I'm going to go ahead and move on. I'm going to construct congruent triangles by angle, side, angle. Now we have 4 different methods. We've done side, 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 just did side, angle, side. Here's angle, side, angle. We can prove this any which way, but I'm just kind of having you practice some of these skills. And again, I'm going to start with the middle one here. I'm going to make sure that I have a segment that's the same length as from this original triangle. I'm going to go ahead and I'm going to let this segment be the one that I make congruent, and then I'm going to make this angle and this angle congruent, and that'll be my angle, side, angle. So let's start with the side. Just draw something that is plenty long. It doesn't have to look exactly like it, but I'm just trying to help you by making that plenty long there. Then you're going to come back and you're going to put the point of your compass right here and measure how long this segment is. Point of your compass, copy how long that distance is. Now you know that that leg is going to match the given leg. Now what I'm going to do is copy these angles. So put the point of your compass right here and put an arc through here. And since you're copying it, you come down here and make the exact same arc. And then what you're doing is you're going to measure how wide is the arc along there. So I put my point here, measure how wide it is. Copy that, put my point here, copy how wide that was. And then I'll come back, and I don't really know how long that leg is supposed to be, but I just know that that angle is going to create an angle right there, and I'll just extend it plenty high. Now I've got my angle. So I've got an angle, I've got a side that I know how long it's supposed to be. Now I have to do the other angle. So I'm going to start over, put the point of my compass right here, make an arc. Copy that down here, put the point of your compass here, make that arc all the way there. Okay, come back, measure how wide the angle is at that place. Right here, measure how wide it is. And then I know then to make that angle be the same, I have to go from here right through that intersection, keep on going, keep on going, keep on going. There I found my other vertex. And so then I've created this triangle here. Don't do this. Don't go over and over it. I like to, I'm just making this stand out. Here's my congruent triangle. To the original, I made 2 angles congruent and the included side. All right, hope this helps.